Dali T-Series is an all-digital and software configurable platform that enables unified cellular, public safety, and Wi-Fi services over a single infrastructure. It supports multiple bands, multiple technologies, and can support single or multiple operators. Main purpose of the system is to provide indoor and outdoor coverage in the areas that are having insufficient quality of the RF signal. This is due to a fact that the RF signal from the macro cell, when passing through artificial and natural obstacles, incurs a loss, and as a result of that, the RF signal quality suffers. Dali digital distribution system is designed to provide optimum quality of the RF signal, and on that way enables higher quality of service and enhances user experience. Dali T-Series distributed antenna system has a simple two-tier architecture. It's comprised of interface unit and a host unit. These two units are co-located with a base station. The location of the host unit and the interface unit can be at a central office or can be at a venue which actually requires coverage. Third element in a system is remote unit. T-Series features two types of remote units. A T30, which is a mid-power remote, quad-band remote, and T43, which is a dual-band, high-power remote. The interface between the host unit and remote units is achieved by means of fiber optic cable. The transport protocol on a fiber optic cable is modified CPRI. The data rate that T-Series distribution system supports is a CPRI rate 6, meaning that the speed on a fiber per wavelength is 6 gigabits per second. So the operation of the system is as follows. The downlink signal received from the base station is first processed inside interface unit. Interface unit conditions signal from the base station from perspective of power, because usually the signals from base stations are relatively high, from 5 to up to 100 watts. So the interface unit has modules which are designed to accept downlink input power up to 100 watts, the module RFC 50, or dual band module that can receive power up to 37 dBm or 5 watts. These modules are housed inside 4RU 19-inch rack chassis, and there is 12 positions, 12 universal positions with different type of modules can be plugged in. After the signal is conditioned, it is delivered via RF cables to the host unit. Host unit translates that RF signals, or translates those RF signals into a data stream, and serial data stream with a data rate of up to 6 gigabit per second is sent via fiber cable to the remote location, to the actual remote units. The medium or type of the fiber can be a single mode or multi-mode, or in cases where the distances between the host and the remotes are relatively short, like in an indoor environment. Also category 5, 6, or 7 twisted pair cable can be used for that transport. Digital data stream that is transported via fiber optic link will be received by remote unit. Remote unit will translate back that data stream into a RF signal, amplify that signal, and via antenna broadcast that signal to the users. This is a typical example of the wideband indoor antenna for indoor coverage. System supports multiple bands. For North American market, system supports 700 MHz band which includes lower ABC and upper C, 850 MHz band, PCS band, including subband G, and AWS band. We also support Sprint 800 and 2300 band that is currently dedicated to AT&T. For Europe, bands 900, 18, 21, and 2600 are supported. This system also supports public safety bands, 150, 450, or UHF, VHF, UHF, also 700, 800, and 900 MHz bands. So that will be a signal flow on a downlink path from the base station to the remote units and to the user. On an uplink path, the signal flow is opposite, meaning that the RF signal is received by remote unit, inside remote unit translated to data stream, transported over the fiber optic link to a host, where it's translated back to RF and delivered to the base station. The speed of 6 gigabit per second supports aggregated RF bandwidth of up to 164 megahertz. So we'll cover now details related to a host unit. It's a quad band unit housed in a 1RU 19-inch rack chassis and mounted in a standard 19-inch rack cabinet. The ears can also be adopted. The separate ears can be used to mount the unit in a 23-inch cabinet. T-host unit receives the signals from the base station over simplex RF interfaces, translates those RF signals into a digital data stream, and then via optical interfaces translates them or transports them to the remote units. Interfaces on a front panel are as follows. We have an on-off switch for the minus 48 volt power. The unit is powered by the minus 48 DC voltage. The two Ethernet interfaces, the first one is to connect the unit to the wide area network. The second one is to deliver the traffic from the IP appliances connected to the remote units to the Ethernet backbone. We also have a local Ethernet port used to connect a laptop so the user can directly browse into the web server located inside the host unit and get graphical user interface pages or GUI pages, which will enable him to control and monitor the system. So on the RF side, there are 8 simplex SMA connectors, and there are RF interfaces towards the base station. Simplex, meaning that each band has TX input and RX output. TX is downlink signal received from a base station. RX out is an uplink signal delivered to the base station. T-host is a quad band unit, hence 4 pair of SMA connectors. T-host features 6 optical interfaces, each one able to deliver data at data rate of up to 6 gigabits per second. So from here, we can create a different network topologies, different topologies of the remote networks. One type of networking is a star network. The host unit is the center of the star, and the 6 optical interfaces can create 6 spokes towards the remotes. Remotes can also be daisy-chained or cascaded. So that's a second type of networking. And finally, we can combine those 2 types of networking and create a hybrid network, star and daisy chain. Number of remote units that can be connected to a single host depends on 2 main parameters. One parameter is round-trip delay. It's actually a total delay from the base station through the system, user, and back to a base station. This round-trip delay is technology specific, and the most demanding technology or waveform is LTE. The second parameter is aggregated noise. Depending on how the base station is connected to the distribution system, higher or lower noise level can be tolerated. The host units can also be daisy-chained, or cascaded. So besides cascading remotes, we also have capability to cascade the host units. There are two purposes for this cascading. First one is adding additional band or adding additional operators, where each operator has a dedicated host unit. By cascading them, we are aggregating RF signals, but this time at a digital level. And in that way, we are avoiding PIM problems. Cascading can also be used to manage multiple sectors. So different sectors will be connected to an array of host units. Cascading or interconnection between the host units will enable routing of the signal, routing of the sectors, and delivery of different sectors to different remotes. On this way, we are able to remotely, via graphical user interface or via software, resectorize the remote area and on that way achieve capacity management. Beside the fact that co-located host units can be cascaded, we can also cascade host units which are at different geographical locations. On that way, content, meaning the base station resources which reside at different geographical locations, can be aggregated together and then transported by fiber optic link to our remote locations. To enable transport on a fiber optic interface, on a fiber optic cable, Dali T-Series distribution system is using off-the-shelf optical transceivers, mechanical package SFP+. These optical transceivers come in different flavors, but they're designed to cover different distances from a short distances to the large one, from 10 kilometers to 40, 80 kilometers. But more importantly, for this application, they come as a result of that coverage with a different optical link budget. They're plug and play. What is currently inside the T-host unit is so-called bidirectional SFP, meaning that it has a built-in optical duplexer, demultiplexer, and operates at two wavelengths. Downlink wavelength 1 sends the signal from a host unit to a remote. On a wavelength 2, uplink signal is received from the remote and processed inside the host. Other interfaces on the front panel are reference in and reference out. In a case of the reference in, that means that the T-host can accept external 10 megahertz reference signal to synchronize the host and all the elements connected to the host. Reference out creates ability to send a reference signal from this host to other hosts that are cascaded, and in that way synchronize the whole network. Synchronization between the hosts that are cascaded, beside synchronization of the over the RF interface, can also be achieved over the fiber optic interface. Finally, we have a cluster of LEDs on the front panel. Power LED shows the actual applied power. It is green when the power is applied. Run LED shows health status of the microprocessor. Communication LED shows the actual health status of the link between the host and the remote unit on optical fiber. Alarm LED will go red in a case of the major alarm or orange in a case of the minor alarm. And finally, this cluster of 4 pair LEDs is related to downlink and uplink path of each band. In a case that uplink and downlink paths of all bands are enabled, all 8 LEDs are green. If some of the paths are disabled due to the fact that that band is not in use, or we're doing some testing, those LEDs will be off. The T-host unit is a forced air-cooled unit. So it has 2 fans on the back, and the airflow is from the front to the back. The fan assembly is designed in a fashion that it's very easy to replace them. So in a case of the fan failure, by removing 4 screws and unplugging the inline connector, the failed fan can be easily removed. In the same fashion, in opposite order, the new fan can be placed at the same location. Finally, we have a ground terminal at the left-hand side of the unit where the ground lug can be connected and unit properly grounded. A T-series distributed antenna system has 2 types of remote units. T30 is a quad-band mid-power remote with output powers per band of 1 watt. And T43, a high-power remote. It's a dual-band unit with maximum output power of 20 watts per band. Functionality of remotes is as follows. On a downlink path, they're receiving data stream via fiber optic link. That data stream is translated into RF signal inside the unit, and after amplification, filtration, and other RF functions, distributed to single or multiple antennas. And then signal is broadcasted to the user's phone. On an uplink path, user phone will reply with a signal, RF signal, that will be received by antenna, transferred to a remote unit input, RF input, and then inside the unit translated back to a digital data stream and via fiber optic interface delivered back to the host unit. The T30 unit can be installed on the wall sideways as shown here, or on the back as shown in this section here. The installation is done by assembling first the mounting plate on the wall and then hanging the unit so it latches in the openings available in assembly plate. The T30 unit is convection cooled unit. Means that there are no fans. The heatsink, which is on the back of the unit, is positioned vertical, and in that way the cooler air goes over the fences of the heatsink and goes up. So the T43 unit can also be installed on a wall or on the pole. The installation on the wall is similar to installation of the T30 unit, meaning that installation plate is first secured to the wall and then unit hanged in position and secured with 2 screws. For installation on the pole, mounting plate like this is used. So first, the mounting plate is affixed to a pole. In a case of the wooden pole, the bolts are driven through the pole. In a case of a metal pole, straps like this are used to secure the mounting plate to the pole first in 3 locations, and after that the unit is hanged in place and secured at the bottom with 2 screws. This is a T30 unit, part of the T-Series platform. This is connector interface. Connectors present are, from right to left, the DC connector. Unit is powered by -48 volt DC, and this is the connector where the cable with appropriate power source is plugged in. We have 2 Ethernet ports. One is a local Ethernet port where the user can connect his laptop and gain access to a graphical user interface, and on that way see the telemetry and be able to control not just this remote, but all the remotes and all the hosts which are in the network. The second interface is 1 gigabit per second interface that is designed to accept or to connect to third-party appliances like IP camera, Wi-Fi access point, or mini base station. In this way, our system acts as a backhaul for those IP appliances. Unit has 6 optical interfaces, so on that way can receive a single optical connection from the host or multiple optical connections from the host. This feature is used in a case of optical link redundancy, for example. The other ports are used to daisy chain other remote units, T30 or T43, in a daisy chain topology or a cascaded topology. This is a monitoring cluster of the T30 unit. The first LED is related to power. So when power is applied, green color will be displayed. The second one is run LED. It shows the health status of the microprocessor. The third one is communication LED, shows the health status of the link between host and the remote. Alarm LED shows any alarm condition in the unit. No alarms, green color. Minor alarms, orange. And finally, major alarms, red. The cluster of 8 LEDs is related to transmit and receive path or section of the 4 bands. When those sections are enabled, the LEDs are green. If any of the sections is disabled for any reason, testing purposes or so on, the LED will be off. On top of the optical interfaces, we also have a set of LEDs for each optical interface. First LED shows that the SFP is plugged in. The second LED shows the synchronization between the host and the remote unit. Blinking second LED means that synchronization between host and remote is established. And finally, we have RF interface, N-type connector. This antenna interface is aggregated interface since we have a built-in multiplexer that aggregates all 4 bands into a single point. So this is T43 remote unit. It's a sealed unit, IP65 compliant, due to the fact that it's forced air-cooled unit with the fans on the top, forcing the air over the fences and heatsink that is on the bottom of the unit. The fan assembly is IP55 compliant. Connectors from right to left are as followed. We have Ethernet connector, RJ45, so user can plug in his laptop and gain direct access to graphical user interface pages that can enable him to control and monitor the system. Not just this particular remote unit, but all other remote units and the host units that are in the network. Panel also contains two optical interfaces, dual interfaces. So the unit can receive optical interface or optical cable coming from the host unit, and also can, over a second connector, daisy chain a next T30 or T43 unit in a cascaded or daisy chain topology. On the bottom here, we have a battery backup unit, battery backup connector. This is AC powered unit, and the main power is applied over the AC connector here. But in a case of AC power failure, battery backup will be applied via this connector. Beside the battery, we have a control and monitoring connector, which enables dry contact interface of the third-party appliances, and on that way communication of their alarms to the host unit. Finally, RF interface connector or RF antenna connector. This is DIN 716 type RF connector, and the unit can have one or two of them. This is a dual band unit. In a case of having a multiplexer that combines two bands, we have a single connector. But in some cases, based on actual venue, we can have a separate antenna ports for each band. So T43 remote unit is a forced air cooled system. It features fan assembly at the top of the unit. We'll demonstrate how easy it is to replace fan assembly in a case of failure of one or the other fan. So first step is to remove the cover. Second, we'll undo two captive screws which are holding fan assembly in place. Then we'll undo the cable interface and remove the fan assembly. Putting back the fan assembly will be done in opposite order. We plug in fan assembly, secure with two captive screws, re-establish cable interface, and put the cover back. Using a built-in web interface, user can easily connect to a laptop, connect his laptop to the internet port, local port, and on that way gain access to graphical user interface. Graphical user interface is used during commissioning of the system and also for monitoring the system during operation. Graphical user interface provides multiple functions related to control, related to monitoring, and also provides alarms that may happen inside the system. Control and management of the T-Series platform can be achieved using Element Management System, or EMS, Network Management System, NMS, or SNMP signaling can be used to communicate alarms, traps, to Network Operating Center and receive a control and monitoring commands from the Network Operating Center. We'll demonstrate how easy it is to log into the Element Management System and we'll show main features of related to control, monitoring, and alarming of the system. So to reach graphical user interface, user can simply browse into a web server located inside the host unit. So appropriate IP address is entered and username and password entered upon request. Main GUI page appears. So these are the subsections of the GUI page. On the left-hand side, we have a product or network tree. Network tree shows all the elements that are in a network. So currently, we have a host connected to 2 remotes, and that connection is star connection. In a case of a daisy chain connection, another line on the right-hand side of the unit names will appear. On a product tree, we also have indication about the health status of the unit. So if everything is fine, there are no alarms, units will be green. In a case we have a minor alarm, the icon beside the unit will turn orange. And finally, in a case of a major alarm, that icon will be red. So we're going to review first the host page. Host page is comprised of a couple subsections. Since this is a quad-band unit, we have 4 subsections which are presenting control and monitoring features related to particular bands. So first section is related to band 900, second section to band 1800, third to 2100, and the last one for 2600. The last subsection on a screen is related to the unit, to the system, shows system elements. So we'll start with that. We have a serial number of the unit, software revision of the unit, the temperature telemetry inside the unit, and we're also measuring input voltage, input DC voltage that's applied. We have alarm section, and in this particular time, there are no alarms in a system. The actual band subsections contain the following information. All the fields with a white background are control fields, meaning that we can enter values and change that particular parameter. All the fields with a gray background are representing telemetry. They're showing readings received from the unit. So in a case of the host unit, we can set downlink attenuation and uplink attenuation. Range for the attenuation is between 0 and 30 dB. In regards to downlink thresholds, we can set downlink input power low threshold and downlink input power over threshold, which means that in a case that downlink signal received is below the expected level, the alarm will be generated, low-level alarm. In a case the level is higher than expected, the high power alarm will be generated. At the same time, this subsection is showing downlink input power and also uplink output power. In this particular case, we don't have a signal supplied, hence the numbers are in a -100 range. And finally, we have ability to control downlink and uplink section of this particular and each band. So we can turn on the uplink or downlink section, or in the case of when we don't use this particular band, we can turn the RF circuitries related to downlink and uplink processing off. The same thing can be applied in a case when we're doing troubleshooting or testing in a system. And finally, we have alarm related to each band. So that's the main graphical user page related to a host unit. To configure the host, we go to the bottom, go to Config tab, and configuration page should appear. So here are the elements that we're configuring in a host unit. This is part of the commissioning process. So I'll start with the network configuration first. So we can select static IP address assignment or dynamic IP address assignment. Usually setup is on a dynamic side, so all the remote units, IP addresses to all the remote units in a network are automatically assigned, and user doesn't need to do anything. We also selected the NTP server, which will be used to provide the proper timing to the system. And a final section is setting the IP address of the SNMP manager. The host unit contains IP client, which communicates to the SNMP, contains SNMP client, which communicates with SNMP manager that is located at a network operating center. We need to provide the proper IP address of the SNMP manager so the host unit can properly communicate with the network operating center. So that will conclude all the setups related to networking. Beside that, we're able to set optical interfaces. We're able to enable or disable optical interfaces. Simply, not all optical interfaces are usually in use. So depending on the size of the network, depending on a number of spokes in a star configuration towards the remote units, only certain only certain optical ports will be enabled. By hovering on top of the icon for a particular optical port, we can get telemetry related to that optical port. We're measuring, or system is measuring, laser, TX power, and also the pin diode receive power. So we can see the temperature inside the SFP. So these measurements are actually from the pluggable optical transceiver. Okay. In a case of cascading the host units, this row here is used to enable cascading and to define which of the host units in a cascaded network are actually prime, meaning the ones which are providing clock reference, and which ones are slave, meaning that they're receiving clock reference. This section is related to the bands. So again, in some cases, not all the bands will be in use, and in that case, the band can be disabled just by clicking here. On this way, the alarms generated by that band are not going to be communicated to the network operating center anymore. Also, in a case of a neutral host environment where multiple operators are served over the network, power allocation can be defined in this subsection of the bands. And in a case of European bands where we have particular capability of working on a particular section of the band, sub-band selection can be performed using this section. So if we move back to the main page of the host unit, we see that we have alarm on a band number 1. If I hover over the alarm icon, I'll get information that downlink RF is in a shutdown and uplink RF is in a shutdown. And at the same time, the user will get a tip what he needs to do to clear this alarm. So the alarms are due to the fact that we disabled downlink and uplink path. By enabling back uplink and downlink path, the alarm will disappear. Moving to remote graphical user interface. Similar to the host, the remote graphical user interface page is comprised of 4 subsections, each one representing a particular band, and a system subsection. So the system subsection at the bottom provides information on what is the optical delay to this particular remote, and shows a compensation applied. Provides also serial number, software version, and temperature inside the unit, and a system level alarm or unit level alarm. Each of the band subsections are providing a following functionality. On a downlink side, we can apply attenuation to downlink path, and on that way reduce the output power going out of the remote. And we can also get the telemetry on what is the downlink system gain. So at this moment, since the downlink attenuator is 0 in the host and the remote, we have a maximum system gain of 47 dB. On the uplink side, we can do the same thing. Apply attenuation to the uplink and observe the system gain. Since we didn't apply any attenuation here nor in the host, we have a full maximum uplink gain of 40 dB. Usually the uplink gain adjustment is done in a host unit to preserve the best noise figure. In this section, we're seeing telemetry on a downlink output power and uplink input power. And finally, on the right-hand side, we again have an ability to enable or disable RF sections of the downlink and uplink path inside the remote unit. And finally, we have alarms related to particular band. So that is a main graphical user page for the remote unit, T30 remote unit. To configure remote unit, we click to Configuration tab, and here we have ability to enable or disable optical ports. Optical port 1 is enabled by default, and we see telemetry from the SFP plugged into optical port 1. In a case that this unit is in a daisy chain or provides a signal to the next remote unit in a daisy chain, a port 2 will need to be enabled. Finally, we have ability to enable or disable any of the remote bands. So if a certain band in the remote is not in use, we're going to disable that band here, and on that way alarms generated on this band due to the fact that it's not in use, meaning low downlink power or similar things, will not be reported to the network operating center. So these are one of the main functions that remote graphical user page is providing. So again, just to demonstrate alarming, we got alarm on a 2600 band. This is due to the fact that I disabled and then re-enabled this band. During disabling, the uplink and downlink RF path of that band was disabled. So by observing here, I'll see the alarming report that downlink RF is in a shutdown and uplink is in a shutdown. We can rectify that by simply enabling those ports, and alarm will disappear. It will require a couple seconds to refresh. It's already refreshed on the main screen. Here it is. So these are some of the main features of the graphical user interface for T-Series. Commissioning process is, as shown, very simple. We go to a configuration page of the host, configuration page of a remote, enable particular elements which are in use, do the delay compensation, and finally, based on desired output powers on the remote, adjust attenuation on the downlink path, and finally adjust attenuation on the uplink path, and commissioning process is concluded. Few points to conclude overview of the T-Series platform. T-Series platform is simple, flexible, elastic, future-proof architecture, very easy to commission. Simple because contains only two elements in a system, the host unit and remote units. Flexible because by cascading host units, different sectors can be routed to different remote areas, and in that way enabling capacity management on when needed, where needed basis. That enables efficient use of centralized base station resources. It's elastic. It can easily be expanded by adding bands and units, by daisy chaining the host units at the central office and daisy chaining the remote units at the remote locations. It's future-proof because all digital signal processing is conducted inside reprogrammable devices, field programmable gate arrays, or FPGAs. It's easy to commission, intuitive control and management system with advanced software features like automated delay compensation, software configurable AOC thresholds, software configured other alarm thresholds, enable simple and easy commissioning. All of these features are leading to significant capital and operational cost reduction. Thank you for watching Dali T-Series Distributed Antenna System Overview.